Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, welcome to Industrial Talk once again, the numero uno industrial-related podcast in the universe that celebrates industry heroes all around the world and companies. Put that down. Because you're bold, you're brave, you dare greatly, absolutely. You innovate, you solve problems, and you're changing lives, you're changing the community, and as well, changing the world. Come on, that's why we celebrate you. That's why you're cool. All right, in the hot seat, we have a gentleman by the name of Prith Banerjee, CTO. Ansys is the company. We're talking digital twin, but we're talking about the ability to simulate using data analytics, simulation, and honing in on that answer. Let's get cracking. Innovation. It's cool stuff, right? And it is necessary. And if you're not doing your homework and getting in that or talking to trusted sources about innovation technology and whatever it can do and how you can leverage it, I ask you to do it now, right? Industrial Talk has trusted individuals go out there and just begin that journey. Have those conversations because you need it. You just do. We need for you to be resilient. The world is changing all the time, and you need to leverage technology and innovation and talk to trusted people to be able to create that business of resilience because we need you. We need you big time. All right. When we start talking about innovation, I've got two sponsors that you need to check out big time. And because it's cool. So AI Dash, right? Go out to AI-.com and they're able to use the technology, satellites specifically, to help you with your vegetation management, right? Utility vegetation management. As an old crotchety, crusty journeyman lineman, I knew how I had to trim trees, and it was all reactive. Trust me, it was reactive. Run out there, trim. Oh my gosh, there's another one. You tried to make it sort of strategic, but it never is. You just got to run out there, grab the bucket truck, trim it, boom, move on. Here's a solution, AI Dash, that looks down on your service territory and says, yep, go right there. Go over here, trim that tree. Yep, go over there and trim that. No, don't go over there. That's fine. Isn't that good? I mean, that is deploying your capital, deploying your money in a way that really benefits us, the consumer, so that the service stays up and running and delivering the power that we need. AI Dash, they're leading the way. That's satellite AI vegetation management simplified, baby. All right, and the other one is Neom. So you go out to neom.com. And I have this conversation all of the time. I talk to innovators, I talk to technology deliverers and service providers and everybody, and we're talking about digital transformation, we're talking about AI, we're talking about quantum computing, we're talking about all of the topics that are really a buzz today. And the reality is that here's Neom, they're going to put it into action. They're creating a community of the future. And they're going, you know what the best part about it is? They're going to make our lives better. They're going to go down that road. They're going to get the bumps and bruises. They're going to try to figure out solutions that really are meaningful to us. Neom, right? Meaningful to us, solve those problems, and we as a society benefit greatly. It's cool. Don't you? Come on. You got to get all, jittery happy with that stuff. That's neom.com. They're creating the community of the future, and they are doing it. They're doing it. All right, neom.com. Go out there. All right. So one of the things that I've talked about is getting the most out of, right? Getting the most out of. Are you getting the most out of conferences? Are you getting the most out of your engagements, whatever it might be, getting the most out of your campaigns, whatever it might be? Are you? And ask that question and be truthful about it. Are you? Or is there ways of being able to improve that engagement, that conference, that whatever it might be? And I'm here to challenge you. There are strategies, there are solutions that are out there. And one of them is, okay, people ask me, Scott, why do you podcast? Well, one, it's fun. Yeah. And it's available for everybody. But one, it's fun. And two, I get to talk to leaders around the world. And these leaders are movers and shakers, and they are at the cutting edge of thinking and deciding what's good. You need to be there. You need to earnestly, and I mean earnestly. There's ways, and I'm going to continue to sort of add to this, but at a minimum, look at creating a podcast. And I have a program out there that says why you need a podcast, and it takes you every step of the way, right? But the reality is that if you want to get the most out of something, have multiple touch points and engagement that you can offer to your prospects, your customers, whatever it might be, bring life back to a blog. There's no better way. There's no better way of being able to do that. Yes, there's a lot of podcasts out there. What we do at Industrial Talk is we recognize that there is this fragmentation that exists out there, right? There is. Podcast over here, podcast over there, and so on and so forth. Great content there, solutions here, right? What do? Well, I'm in the game of consolidating that. I'm in the game of trying to bring all this great thinking together so that the industry, the community, the ecosystem has a place to go and says, I want to know about cybersecurity. Boom. From a trusted individual. Right there. Boom. Easy, right? And because typical topics tend to be very niche, it's the reality is you tap out the opportunities there. So you need a community to be able to be a part of, fly in formation, to be able to be impactful and have your doggone message be heard. You got to have it heard, right? People got to listen to it. If they don't, like, does a tree make a sound when it falls in the forest? If you're not there, I don't hear it. I don't hear it right now. The same thing exists with your voice. You got to do it. And we'll talk a little bit about it, but I just tell you, just go out to this podcast and other podcasts will say, why do you need to do a podcast? You got to do it. You got to figure it out. Contact me. Geez, I'm an open doggone book. I am. I'm warm and fuzzy and cuddly. Well, maybe. I could be more cuddly. Anyway, all right, let's get going. So what's interesting, and had a great conversation with Prith. And what's interesting is the ability, yes, we can collect data. It's all good. Collect. But what about that simulation component, right? It's great. Got all that data. Let's simulate what's taking place. Let's simulate what might happen or whatever, and be able to, without a doubt, begin to converge the data and simulation into a true, cogent response or information on when you need to perform maintenance, perform whatever corrective action, whatever it might be. Simulation is, it was great talking to Prith because you could tell he's pretty passionate about the whole thing, and rightly so. Rightly so. All right, let's get cracking. You don't want to hear me yammer on. Here's Prith talking about digital twin, but really simulation. Enjoy. Welcome to Industrial Talk. Thank you very much. Broadcasting from Palo Alto. That's where he is coming from. If you're out on the video, you'll see that there's plenty of sunshine happening there. Anyway, how you doing there, Prith?
Very good. Thank you very much, Scott, for having me.
I'm excited about this conversation. Okay, listeners, we're going to be talking digital twin. And you're saying, Scott, I don't want to talk. Yes, you do. You want to talk digital twin. But more importantly, I think Prith is going to bring a wealth of knowledge that you're just going to be dazzled by him. And I know he is. So, Prith, before we get going, give us a little sort of 411, a background on who Prith is.
Sure. So I'm Prith Banerjee. I'm Chief Technology Officer at Ansys. Ansys is a modeling and simulation company. We are a company of about $2 billion in revenue, 5,000 employees. We help provide solutions to our customers in terms of when they are trying to design products. We enable them to design, develop the most amazing products in areas such as automotive or aircraft, aerospace, or manufacturing and energy and so on. So that's what Ansys does. And my role as Chief Technology Officer is to set the long-term technology strategy for the company. around areas such as AI, machine learning, high performance computing, digital twins, and so on.
Whoa! You just threw out a hyper comment. What was that?
High performance computing.
High performance. Yeah, I'd like that. See, you're sitting in the seat where a lot of people want to sit, just because you get exposed. I mean, you must see a lot of innovations just coming. I mean, just constantly evaluating, looking, having a conversation around innovation and the impact it has on industry, society. I mean, it's pretty cool. You're living a dream, baby.
I have the most fun job at Ansys, I'll tell you.
You do?
We have 45,000 customers. Every day I talk to sort of CTOs of different customers across different verticals, from aerospace. Like today I had a meeting with a CTO of a medical device company. Yesterday I had a meeting with a 5G company. So I'm learning about the future trends in these different verticals. And then from my own team members, right, I get to learn about the newest, coolest technologies of AI, machine learning applied to simulation, or high performance computing, or digital twins, or prime meshing. It is a fun job. And
it is. And I've never seen it so. There's such a speed, a velocity that's happening out there, and it's exciting. But man, that's pretty cool. So let's start diving into that. Let's dive into digital twin. Now, for the listeners out there, give us a little, just what is a digital twin? And then we're going to go into some of the challenges and opportunities that exist within that technology.
Absolutely. So a digital twin is a virtual replica of a physical asset. So let's say you have a jet engine of a plane, right? And that jet engine originally gets designed in a CAD tool, right? You say, here is a engine, it has all these blades and so on. And you design that jet engine on a CAD tool. Then you actually manufacture the jet engine, and it gets installed on a United Airlines plane, and this jet engine is flying around and so on, right? That is a particular jet engine. Now you try to make a model of that engine, and oftentimes people confuse, oh, you have a simulation model of the engine, that's a digital twin. That's not. That is just part of it. So a model of a physical asset like a jet engine is one thing. The other thing is there has to be two-way information flow between that physical asset, the jet engine, and the model. And that's what makes it a digital twin. So you have the jet engine, you put sensors on the jet engine, right? And you collect all those data from the sensors, you upload to the cloud or whatever. So you're pulling that information. And using that data that you have from that jet engine, you try to make the model of the jet engine as accurate as you can, right, with respect to what is in the real thing. So it's like a virtual replica. So I am Prith, I have a model of Prith, and this model of Prith keeps getting updates, right? Here is Prith, really excited. So the excitement level is going there, right? Prith's temperature is what, 98.4, right? So it's constantly measuring what is happening on the real asset and updating the model at the same time. So a digital twin is not a model of a jet engine. It's a model of a particular personalized model of that particular jet engine, right? And how that is going on in time. So this is something that NASA used many, many years ago. If you have seen the Apollo 13, the wonderful thing, sort of the picture, the movie about Apollo 13, right? When that Apollo 13 had an accident, right?
Yeah.
The people in Houston, right? Hey, Houston, listen to Houston, right? And those engineers at NASA actually built a digital twin of Apollo 13, and they said, oops, if you do this, this is what happened. So essentially they created a model of what was happening and sent out the instructions to the astronauts, and that's how they brought it back. So
see, that you just brought it to it. And I guarantee a lot of people are listening is like, yeah, Apollo 13. I remember him sitting in the capsule, switching and doing everything and making sure the amperage didn't, whatever that target was, do this. But that makes complete sense.
That model was happening in Houston, right? So
yes.
They had a physical asset out there in space, and they had a model in Houston, and essentially all these scientists were trying to do stuff. What if this happened? This will blow up. So they said, okay, this would work. and they send those instructions, and that's how the astronauts were brought back.
That's
so
pretty cool.
so that's digital twin back in so long ago, right? In the 80s. But essentially, the digital twin technology has come a long way since. But that's what digital twins are. It's a model of a physical asset with two-way information flow between the physical asset and the model.
And why is that important? It just gives me, the individual, able to look at the characteristic of that asset, that real asset in a digital environment, and see what's happening, and then I can tactically move forward in some decision making or whatever it might be.
Precisely. So let me give you an example. So we all rotate tires in our cars, right? We rotate tires every 5,000 miles. Why is that? Because all the tire companies have said statistically, if you drive your tire around on a normal road, normal driving, your tire will wear this much, and this is going to happen. Except if Prith driving crazily on US 101 in San Francisco with lots of potholes, I probably need to rotate my tire every 3,000 miles, right? So that's personalized driving. So you take the statistics of all possible cars, all possible drivers, and that's how people say you should change your oil every 10,000 miles and change your things. That's called preventive maintenance, right? So why do you do preventive maintenance? You replace your oil, replace your tire, etc., so that your tire does not burst, your engine doesn't conk out. In the world so there is this preventive maintenance that people do. Now imagine if you could predict exactly when that engine would conk, so just the day before you replace the oil, that would save a lot of money.
Yes.
The question is, can you predict accurately?
Yes. See,
and that's what the digital twin comes. So what the digital twin does is you have the physical asset, the engine or a car or a medical device or whatever, right? And you are monitoring it and you are getting real-time information and say, oops, it's about to fall sick. So we humans, we fall sick, right? Before we fall really sick, you get a temperature. You get, I'm feeling a little lousy, I'm having an ache. So those are signals that you're about to fall sick. Then when you get 103 temperature, you are boom, right? So imagine if you could sense things around you, you could do predictive analytics, and that would be huge because suppose you have the data center for Google or Amazon. Imagine that data center going down, that would create tremendous waste, right? 5 minutes of downtime on Google or Amazon would be hundreds of millions of dollars of thing waste, right? If a power grid goes down, electricity goes down, tremendous waste. So people in these essential industries, they are critical infrastructure assets. They don't want them to go down. So what they do is they try to predict when this is going to fail, and before it fails, do the corrective action. So the real deal here is, can I predict it accurately? That's the name of it.
See, that is because I lived that, right? I was in that world. I was in the world of maintenance. And when you spend a maintenance dollar up here on the financials, it's a dollar down at the bottom, right? And if you could sweat the asset and sweat it in such a way that you know when to perform that maintenance before it catastrophically fails, I've saved that much time, that much money. And you don't have a catastrophic failure that could put you out for who knows how long, whatever it is. How do we get there, Prith? That we've been having that conversation. People understand the value of that predictive capability. When do we really start to see it happening commercially?
So I will actually tell you sort of the technical challenges, then the business challenges, right?
Yeah.
So the world, again, there's this thing called the Digital Twin Consortium that I am a part of, and there are some founding members like Microsoft and GE and Ansys and so on, right? So I've been in this business for some time now. I've sort of lived it and so on. Prior to Ansys, I did not tell you, I used to be CTO at ABB, CTO at Schneider Electric, and when I was on those companies, I was helping build digital twins of the assets of ABB and Schneider Electric, right? So they have a transformer from ABB. You collect all the data, right, from sensors, and you just by collecting data, you try to build a digital model of that transformer in the normal behavior, and the apps, as soon as it starts giving signals of abnormal behavior, you say, oh, bad things are happening, shut it down, right? So the most of the world uses digital twins based on data analytics alone, right? So they collect data, and they collect lots and lots of data, right? Sort of
tsunami of data,
terabytes of data.
Yeah.
And from those data, they use AI machine learning techniques, right? All the world knows about AI machine learning. You train those sort of these convolutional neural networks, CNN models, and there's 6-stage neural networks. So there's a lot of work that people have done in this community using AI, ML, CNNs, etc., to build these digital twins based on analytics alone. Now, when I was at ABB and Schneider Electric, we used to do all those things, and we found that, you know what, it was not that accurate. So yeah, it's say 70% accurate. So we said, oh, 70% is pretty good. You have $1 million asset, you're 70% accurate, means you made a 30% mistake. 30% mistake is $300,000.
Yeah, I was going to say, that's a lot of money.
That's a lot of money. So clearly, this is what the challenge was. So in the industry, people said, oh, if you did pure analytics, right, it's does not always work. Now, analytics works in cases where you have enough data on the use case you're looking for, right? So for frequently occurring events, data analytics goes well. For infrequent events, you cannot predict it. Let me give you a very bad example. Space Shuttle Challenger exploded.
Uh-huh.
How many times has a space shuttle extended? Once. So you can get all kinds of data on space shuttles, and so on. You would never be able to predict when that space shuttle would explode, right? So that is an infrequent event. So when an event is happening all the time, right, you have little things that are little nut bolts or whatever that are sort of breaking down in this thing. Frequently occurring events, AI/ML is great at catching. Infrequent events, you cannot go there. So this was my aha moment. Oh, okay. So what can we do? Therefore, simulation. So now the world around us is governed by simulation, right? Governed by the laws of physics, which you can model really, really accurately. Let's imagine you have a bridge and you're trying to predict when that bridge will collapse, right? So that you can shut down the road, right? So you put all kinds of sensors on the bridge and you say, hey, is there a crack on the bridge or not? So first of all, you can say, how long do bridges last? 30 years. So you said preventive maintenance of the bridge every 30 years. Every 30 years, you go and fix the bridge or whatever, right? That's the preventive maintenance way. The IoT way is to put sensors on the bridge to see, is there a crack on the bridge or not, right? So let's imagine that there are cracks on the bridge. I said, here is a crack that is 12 inches long today. Now, you have no idea where that crack would go next week. But if you had simulation using, say, structural analysis, finite element analysis with Ansys tools, I'm telling you, Scott, I can predict with 1,000 cars going on the road with this kind of speed and so on, what is the stress strain on the bridge? And if there's a crack that is with steel pillars and so on, with this 12 inches, I am predicting through simulation that this crack will grow to 18 inches in a month through simulation. So if I did that through simulation in a month, if I did pure simulation, I would say this crack, which was 12 inches long, 18 inches tomorrow, 44 inches, at 36 inches, it will crack. I will predict through simulation alone that the bridge will crack in a month, and that is a prediction. Through simulation alone, we have found out that the accuracy of this 70% goes up to 90%.
No way.
Okay, so now you have this $1 million part with physics-based simulation. We have a tool called Twin Builder. We were able to increase it from 70 or 80% to about 90%. So that $1 million part, your waste is now only 100,000. You're saying only 100,000, and still a lot of money. So that's where we had this aha moment, right? Where we said, let's do hybrid digital twins. Let's combine the data analytics with the physics. So now I'm going to bring it together with an example. Here is this bridge. We had a track, we had a crack which is 12 inches long, right? Through data, I measured it through data analytics, right? And I predicted it will be 18 inches long a month from now. But a month from now, I take the measurement and the crack actually was only 16 inches long. So my simulation model was making a prediction. It was going too fast.
Right.
So my data analysis is saying, hey, go slow. So it goes slow. Or, for example, the actual measured crack was 24 inches long. So that means my simulation was going slower. So by getting a updated information from that's why I say, remember that the two-way information flow, I pulled data from the bridge about the size of the crack, and I made my simulation model more accurate, synchronized with the real thing. So as I change the rate of crack growth, right, instead of making it 18 inches, I correct it to 16 inches or 24 inches, whatever is going on. The next month when I predict, I will be a little more accurate. I'll say it should be 32 inches. And next time I say, no, it should be 31. Oh, so I slow it down even more. So through this hybrid approach with a combination of data analytics and simulation, Scott, we have shown data that the accuracy goes to 99%.
No way. Can you, because this is just cool stuff. Don't get me wrong. I think this is cool stuff. Can you take that bridge analogy and you're honing, you're tweaking, you're zooming in on accuracy by data and simulations, and you're bringing it all together. Can you take that and say, all right, this bridge is in Texas. Let's go to, Florida, and sort of take that learning, that simulation, and apply it. And again,
yes,
tweak, different weather patterns, a little bit more speed of the cars, whatever it might be, but be able to use it there too as well.
Absolutely. And so just like sort of just the AI tool like Siri, right? Your little tool. I mean, so Siri, when it listens to you, Scott, you have an American accent. I have an Indian accent. But Siri, after listening to me for a month, it gets pretty good, right? When I say, go do this, so the machine learning things gets better and better the more data it gets to. Similarly, is hybrid digital twin gets. So there is something you can do with simulation, with physics-based simulation. But the more data you give, the better the model becomes. And this is sort of the state of digital twins that I'm seeing from Ansys, and I'm talking to lots and lots of customers across different verticals. We have got sort of applications in industrial flow networks, working with oil and gas companies, applications in electrification with battery systems and so on, applications in HVAC and buildings and so on. Tremendous opportunities across all verticals.
Where does it end? And when I say that, let's say I'm at 90% accuracy. I can measure it. I've looked at it, my simulation, my data. I'm there and I'm tweaking. And then I put more time, energy, and effort. I'm at 95 and so on and so forth. There's a point where it's like, okay, we're good. We're good. And any additional incremental benefit is just like minuscule.
Yeah. And so that is sort of, it is the law of diminishing returns, right? You plot a graph and you keep seeing it's making change. At some point it is flattening out. And so it really depends, right? For that particular engine or bridge or flow network or valves or whatever, right? When you see that law of diminishing, you are not really getting incremental stuff, right? You sort of stop there, right? That's what we have done.
And wow, the applications are quite frankly endless, because you get it to the point where, let's say it's a motor, right? You do the same thing, data, simulate, and your analogy of Apollo 13, I see a guy in a capsule running a simulation, trying to get it just right. And the same thing exists. You could be on that asset, that pump, motor, whatever it is, but you can apply it, and it might be different in Texas as it is in Maine, right? Just because of the different weather, whatever it might be, different application. But
absolutely. And so now let me tell you, I talked about physical assets, but you and I, we are not just physical assets, we are humans, right? So let me talk about the opportunity of digital twins in the healthcare industry, right? So inside our bodies, right, we have most complicated organ, the human heart. Inside the heart, right, you have a sort of the electric signals that pump, right, that generate the signals 70 times a minute, right? So in response to those electrical signals, the heart muscles contract. So when the heart muscles contract, the atrium, the blood flows from the atrium to the ventricle, and then the ventricle for this thing, and the valves open up. And so it's just most complicated organ in the human body. Guess what? I mean, ultimately, those human models are modeled by physics, right? There's electrophysiology, there's mechanics, there's fluid flow. So we at Ansys have actually modeled the human heart. Now, there is a generic human heart that you can model, and you can say, okay, this is what is going on. We can also model Prith's human heart. Prith has arrhythmia, right? And I have an irregular heartbeat problem. So Prith goes into a doctor, takes an MRI scan, CT scan, whatever of the heart, and he measures all those things. And for Prith's specific heart, we can come up with, well, if I have arrhythmia, whatever, you can do bad things, you can do heart surgery and so on, right? The other thing is, I mean, you can put in a implant, right? A pacemaker.
Right.
So how will this pacemaker from a company like Medtronic interact with my heart, right? So a company like Medtronic will have to do clinical trials of all kinds of pacemakers and all kinds of patients and so on, right? But through a digital twin of a human heart, right, you can create all these different models and essentially shorten the time,
compress it big time
for trials of a pacemaker, right? And so that's kind of where we are headed. We are headed in terms of what is called in silico trials, right? Computer-based simulations of thousands of patients. I mean, the future is amazing. Scott.
Wow. See that delivers solutions faster, health, whatever. The health side, I just didn't even think about, but you're absolutely right. Create a little digital twin, correct? And you can run simulations, but it's individually based, right? It's your heart. My heart's different than yours.
We wear things like Fitbits, right? The Fitbit is collecting, exactly, you have a Fit. So
yeah.
It's collecting data on you, Scott, 24/7. So imagine if your doctor had a model of Scott sitting inside, right? And is collecting all this data, right? And let's use my example, right? Prith, a model of Prith. And just before Prith is about to have a heart attack, right? The doctor, just 2 hours before, gets to know a signal. Hey, these signals are going in the wrong direction. Prith is about to calls up the ambulance and sends an ambulance to Prith before he has a heart attack. Look at the value of that.
Yeah. Yeah, that's cool stuff, my friend.
Yeah.
What's the the roadblocks? I mean, this is all good stuff. Let's make it happen today. Let's make it happen tomorrow. Let's put it that way.
As you know, Scott, I serve on the advisory board of the IoT Solutions World Congress. In fact, we have a conference coming up in May of this year, right? And
put that on your calendars, listeners, big time.
Many times. Right? I serve on the Digital Twin Consortium, and still it's more than 300 members in this consortium and so on. So people are excited about the potential of digital twins in different verticals, in manufacturing, in factories, in industry 4.0, and so on and so forth. The thing is, Scott, that shiny toy looks like a shiny toy. Oh, we have fantastic possibilities, right? But when you start actually pulling it together, right, you have to collect all this data and so on, and does it work all the time and so on. So many customers are saying, oh, I like the shiny toy. Let me use the shiny toy in a proof of concept. So you do a proof of concept number one, you waste like 3, 4, 5 months, maybe $100,000 project and so on. They like this. Oh, let's try this other case, right? Let's do POC number 2, then POC number 3. So people in this Digital Twin Consortium talk about the POC purgatory, right? Just always doing POCs before moving to scalable systems. So the digital twin thing is going through this sort of inflection point where it is a lot of promise, but it has not quite seen scalable value across all industries and all opportunities. And that is, I think, what the business challenge is today.
I agree with you, but it's going to happen.
It is happening.
It's going to happen. It's going to be in commercial use, and it's
They say it's like a $26 billion market by 2025. So yeah, it is going to happen.
No, it is.
Market is about a couple of billion, but it will happen.
It makes sense, right? There's no, I mean, it makes sense. You got to do something like that. All right, we're going to have to wrap it up. I hate to, because I enjoyed this conversation. How do people get a hold of you, Prith?
So they can contact me at my Ansys email address, prith.banerjee, that's Prith Banerjee, Banerjee at ansys.com. That's ANSYS.
Yeah.
Or you can search me on LinkedIn at LinkedIn-Prith Banerjee or at Twitter at Prith Banerjee.
All right, listeners, you don't have to worry about it. I'm going to have it all out in Industrial Talk. You'll be able to get a hold of this incredible professionals with no problem. And don't come to me then saying, Scott, I can't get a hold of Prith. You're lying. You're lying out there. Just don't do that. All right, Prith, you were absolutely spectacular.
Thank you.
Your energy's doggone, it's exciting. I love watching you just get all giddy about this stuff, man. It's cool stuff. Good job. Good job.
Yeah, I used to be a professor for 20 years.
Yeah, that's a hard job, by the way.
So that's where I learned how to lecture. But thank you.
Wonderful, wonderful. All right, listeners, we're going to wrap it up on the other side. Once again, we'll have all the contact information for Prith and then some. So stay tuned.
You're listening to the Industrial Talk Podcast Network.
All right, thank you very much for joining once again, Industrial Talk. Thank you, Prith. Thank you very much for saying yes and being on Industrial Talk. Love the conversation. You, listeners, need to reach out to Prith. Go out to his stat card. Go out to LinkedIn. You will not be disappointed. Or go to Industrial Talk, find the link, reach out to him. You need trusted professionals that are at the forefront of thinking through all of this. Prith is one of them. Reach out. Do not hesitate to do that. All right, I'm going to continue to challenge you once again. That is, are you getting the most out of it? The bottom line is we need you. You need to be involved. You need to have that business of resiliency, and you need to do a podcast. You need to create one. You need to figure it out. Again, go out to Industrial Talk. I'll give you the step-by-step, everything you need right there, right now. No excuse. You need to be a part of that. All right. Be bold. Be brave. Dare greatly. Hang out with people that are bold, brave, and daring greatly. Industry's full of it. You're going to change the world. Thank you once again. We're going to have another great conversation right around the corner.